Welcome to the Explainer. Today, we're pulling back the curtain on the most important piece of software on your computer, your operating system. It's the invisible conductor, orchestrating this whole symphony of hardware and software. And without it, your computer would just be a box of silent, useless electronics.
So let's just dive right in with this question. Have you ever actually stopped to wonder why? It seems pretty simple, but managing every single click, every keystroke, and every application you have running is a monumental task. Without something in charge, your computer would just descend into total and utter chaos.
To really appreciate what the OS does, let's just imagine a world without it for a second. Think about your computer's hardware, the processor, memory, the printer, your hard drive. They're all really powerful, for sure, but they're just independent parts with absolutely no way to coordinate with each other.
Well, without a manager, you'd get a complete mess. Just imagine one line from your email followed by half a sentence from some web page, all printed right on top of each other. That right there is the anarchy of raw hardware. And to solve all this chaos, we introduce the manager, the conductor, the benevolent dictator of your computer, the operating system. So the OS brings order to this chaos by playing two really fundamental roles. You can think of it as being both a super helpful assistant and, at the same time, a very strict boss.
And this slide really shows you the two faces of the OS perfectly. On one hand, it's an assistant, the extended machine. Its job is to hide all the messy, complicated hardware details and just give you a simple, clean interface. But on the other hand, it's a strict resource manager, kind of like a traffic cop, making sure every single program gets its fair share of the computer's power.
Now, let's look at one of its biggest jobs, juggling all your programs, or as they're technically called, processes. This whole thing is called multi-programming, and honestly, it's the secret sauce behind modern multitasking.
So how does this magic work? Well, just look at these steps. When one program has to wait for something, let's say for a file to download, the CPU is suddenly idle. It has nothing to do. The OS spots this instantly and switches the CPU over to another task that's ready to go. This super fast switching, called time sharing, happens thousands of times a second, creating this seamless illusion that everything is running all at once.
But all this rapid switching creates a pretty dangerous situation. What happens if two programs try to edit the same piece of data at the exact same time? This is called a race condition, where the final result just completely depends on which program gets there first. It's a recipe for corrupted data and totally unpredictable crashes. The OS solves this by enforcing something called mutual exclusion. It's kind of like putting a lock on the data. Only one program gets the key at a time. Once it's done, it unlocks the data, and then the next program can get access. This simple rule is what prevents those really dangerous race conditions. All right, so beyond managing what programs are doing, the OS also has to manage where they do it. See, every single running program needs its own private little space in the computer's memory. But as you start and stop programs, the available memory gets all broken up, fragmented, leaving these empty holes of all different sizes. So the OS has to be really smart about how it fills these gaps every time a new program needs some space. And the OS uses different strategies for this. Two of the most common are first fit, which is just quick and simple. It grabs the first hole it finds that's big enough. Then you've got best fit, which is more meticulous. It searches for the snuggest possible fit to be more efficient with the space.
And this really highlights a constant trade-off the OS has to make: speed versus efficiency. First fit is faster, right? Because it doesn't have to search everywhere. That can make your system feel snappier when you're launching apps. But best fit, well, it's tidier and wastes less space, which might be a lot more important on a system with limited memory. It's a constant balancing act.
Okay, the OS also manages every single file on your system. It's basically the ultimate librarian for your entire digital life.
And like the quote says, it presents a simple view. You don't need to know the physical track and sector on the disk where your vacation photo is actually stored. The OS handles all that messy, low-level detail, giving you a clean system of folders and file names that you can actually navigate.
So the OS is managing all these fundamental operations you see here: opening, reading, and deleting files, and organizing them into that familiar directory tree. It's what keeps your data from turning into a completely unmanageable digital junk drawer.
So whether you're writing an email, listening to music, or playing a game, just remember that the OS is that unseen conductor, flawlessly orchestrating a massive symphony of hardware and software right there in the background. And the scale of this whole operation is just immense. The OS is juggling all these different parts, switching between tasks and managing resources so carefully that it creates this seamless, responsive experience that, let's be honest, we all take for granted. Ultimately, the OS is the invisible genius that transforms a chaotic box of electronics into a powerful, usable tool. So the next time you click an icon and a program just springs to life, you'll know about the complex ballet being performed behind the scenes, all thanks to your operating system.
And that leaves us with a really big question. As our technology evolves into this world of cloud computing, distributed systems, and AI, what's next for the operating system? The fundamental software that runs everything has to evolve too. The conductor's job is only getting more complex. Thank you for watching.